Fiber optics, or optical fiber, refers to the technology that transmits information as light pulses along a glass or plastic fiber. A fiber optic cable can contain a varying number of glass fibers, from a few up to a couple hundred. Another glass layer called cladding surrounds the glass fiber core. The buffer tube layer protects the cladding, and a jacket layer acts as the final protective layer for the individual strand. Fiber optic cables are commonly used because of their advantages over copper cables. Some of those benefits include higher bandwidth and transmit speeds. Fiber optics is used for long-distance and high-performance data networking. It is also commonly used in telecommunication services, such as internet, television, and telephones. For example, Verizon and Google use fiber optics in their Verizon FiOS and Google Fiber services, respectively, providing gigabit internet speeds to users. How fiber optics works. Fiber optics transmits data in the form of light particles, or photons, that pulse through a fiber optic cable. The glass fiber core and the cladding each have a different refractive index that bends incoming light at a certain angle. When light signals are sent through the fiber optic cable, they reflect off the core and cladding in a series of zigzag bounces, following a process called total internal reflection. The light signals do not travel at the speed of light because of the denser glass layers, instead traveling about 30% slower than the speed of light. To renew, or boost, the signal throughout its journey, fiber optics transmission sometimes requires repeaters at distant intervals. These repeaters regenerate the optical signal by converting it to an electrical signal, processing that electrical signal and retransmitting the optical signal. Fiber optic cables are now able to support up to 10 Gbps signals. Typically, as the bandwidth capacity of a fiber optic cable increases, the more expensive it becomes. Multi-mode fiber and single-mode fiber are the two primary types of fiber optic cable. Single-mode fiber. Single-mode fiber is used for longer distances due to the smaller diameter of the glass fiber core. This smaller diameter lessens the possibility for attenuation, which is a reduction in signal strength. The smaller opening isolates the light into a single beam, offering a more direct route and enabling the signal to travel a longer distance. Single-mode fiber also has a considerably higher bandwidth than multi-mode fiber. The light source used for single-mode fiber is typically a laser. Single-mode fiber is usually more expensive as it requires precise calculations to produce the laser light in a smaller opening. Multi-mode fiber. Multi-mode fiber is used for shorter distances because the larger core opening lets light signals bounce and reflect more along the way. The larger diameter permits multiple light pulses to be sent through the cable at one time, which results in more data transmission. This also means more possibility for signal loss, reduction, or interference. Multi-mode fiber optics typically uses an LED to create the light pulse. Fiber optics versus copper cables. Copper wire cables were the traditional choice for telecommunication, networking and cable connections for years. Over time, however, fiber optics became a common alternative. Most telephone company long-distance lines are now made of fiber optic cables. Optical fiber carries more information than conventional copper wire due to its higher bandwidth and faster speeds. Because glass does not conduct electricity, fiber optics is not subject to electromagnetic interference, which minimizes signal losses. Fiber optic cables are used mainly for their advantages over copper cables. Advantages include the following. They support higher bandwidth capacities. Light can travel further without needing as much of a signal boost. They are less susceptible to interference, such as electromagnetic interference. They can be submerged in water. Fiber optic cables are stronger, thinner and lighter than copper wire cables. They do not need to be maintained or replaced as frequently. However, it is important to note that fiber optics do have disadvantages. These disadvantages include the following. Fiber optics is often more expensive than copper wire. Glass fiber requires more protection within an outer cable than copper. Installing new cabling is labor-intensive. Fiber optic cables are often more fragile. For example, the fibers can be broken, or a signal can be lost if the cable is bent or curved around a radius of a few centimeters. Fiber optics uses. A range of industries use fiber optic cables for reliable and fast connectivity. Computer networking and broadcasting. Computer networking is a common fiber optics use case due to optical fibers' ability to transmit data and provide high bandwidth. Similarly, fiber optics is frequently used in broadcasting and electronics to provide better connections and performance. Internet and cable television. Internet and cable television are two of the more common use cases for fiber optics. Fiber optics can be installed to support long-distance connections between computer networks in different locations. Undersea environments. Fiber optic cables are used in more at-risk environments, like undersea cables, as they can be submerged in water and don't need to be frequently replaced. Military and space. Military and space industries also make use of optical fiber as a means of communication and signal transfer in addition to its ability to provide temperature sensing. Fiber optic cables can be beneficial due to their lighter weight and smaller size. Medical. Fiber optics is frequently used in a variety of medical instruments to provide precise illumination. It also increasingly enables biomedical sensors that aid in minimally invasive medical procedures. Because optical fiber is not subject to electromagnetic interference, it is ideal for various tests like MRI scans. Other medical applications for fiber optics include X-ray imaging, endoscopy, light therapy and surgical microscopy. Fiber optic internet is a type of internet connection that uses fiber optic cables to transmit data. It is faster and more reliable than traditional internet connections, making it an increasingly popular choice for both residential and commercial users. However, setting up fiber optic internet requires specific equipment. In this article, we will discuss the equipment needed for fiber optic internet and how it works. 1. Fiber optic cables. Fiber optic cables are the backbone of fiber optic internet. They are thin, flexible cables made of glass or plastic that transmit data using light signals. Fiber optic cables are capable of transmitting data at high speeds and over long distances, making them ideal for internet connections. 2. Optical network terminal, ONT. An optical network terminal, ONT, is a device that connects the fiber optic cable to your home or business. The ONT converts the light signals transmitted by the fiber optic cable into electrical signals that can be used by your devices. The ONT also provides a connection for your router, which allows you to connect multiple devices to the internet. 3. Router. A router is a device that connects to the ONT and provides wireless internet access to your devices. The router takes the electrical signals from the ONT and broadcasts them wirelessly, allowing your devices to connect to the internet. Some fiber optic internet providers offer a combined ONT and router device, while others require you to purchase your own router. 4. Ethernet cables. Ethernet cables are used to connect your devices to the router. They provide a wired connection that is faster and more reliable than a wireless connection. Ethernet cables come in different lengths and categories, with Cat5e and Cat6 being the most common for home use. 5. Network Interface Card, NIC. A network interface card, NIC, is a device that allows your computer to connect to the internet. Most modern computers come with a built-in NIC, but older computers may require an external NIC for fiber optic internet connections. 6. Optical power meter. An optical power meter is a device used by fiber optic technicians to measure the strength of the light signals transmitted by the fiber optic cable. It is used during installation and maintenance to ensure that the fiber optic connection is working properly. 7. Fiber optic splicer. A fiber optic splicer is a device used by fiber optic technicians to join two fiber optic cables together. It is used during installation and maintenance to repair damaged cables or extend the length of the fiber optic connection. In conclusion, fiber optic internet requires specific equipment to set up and maintain. Fiber optic cables, NONT, router, Ethernet cables, NIC, optical power meter, and fiber optic splicer are all necessary components for a fiber optic internet connection. If you are interested in switching to fiber optic internet, contact your local internet service provider to learn more about the equipment and installation process. Thank you for watching this video.